Hello everyone, welcome to Embedded Systems course with Arduino. In today's session, we'll start with coding our software or firmware for Arduino based embedded applications. We'll start designing basic circuitries such as LEDs and interfacing those LEDs with Arduino in today's session. So let's begin. For Arduino coding, the background is C++. Most of the codes are C++ based, but in addition to that, we have special methods or functions which are written. The macros are predefined and we need to call those macros in our firmware code, right? So as we had discussed, and as also I had told in the last session, that the Arduino code are referred to as sketches, right? So the firmware file or the software file which is generated is in the format of .ini file. Okay, .ino, or you will see this .ini or .ini files. It will be in these formats that the output and sketches are generated, and we dump these to the ultimately the microcontroller. We dump these into the ROM, right? The flash memory, which we had seen of 32 KB, the flash memory of our memory controller, Arduino memory controller. So there these will be dumped. Okay. So this is the brief background of what Arduino codes are based on. So we are talking about some, in addition to C++ coding, which is the basic of all the Arduino based firmwares and softwares. The special methods are this, right? So they are divided into certain categories based on the ports or the board which you saw. So we saw that there were around 14 digital pins, right? 2 to 13 were digital pins, and then there was a ground, so there were in total 14 digital pins. So for those there are certain inbuilt functions which are defined. So first is the digital read. If you want to read the value, right, of these digital pins, so the digital pins can take a value of 1 or 0, right? First of all, so 1 represents what? 1 represents 5 volt, or and this represents 0 volt, right? Analog. So it can only have these two values, right? So these two can be the digital values. Now if you want to read the pin value, so you can give the pin number here, right? So pin represents what? Pin is the actual number you have to give. So it can be 2 to 13, any value it can take, because these are the digital pins which we have. So again, now if you want to write, because those digital ports were configurable as input and output, right? So if you want to drive certain value, or if you want to drive certain output, right? So what macro you will use? You will use the write macro, right? So you will give the pin number and the value. So value can be what? Value you can write high, which means 1, and or you can write low. So these can be the two values. Okay, these can be the two values. Now, but before writing, right, or before reading, you need to know whether, or you need to set the digital output ports as an input or output, right? How do you do that? So for that you have this pin mode function inbuilt, where you again give the pin number and you drive the mode. So mode can be what? Mode can be obviously two. One is the input, right? Or it can be what? It can be output. So these can be the two mode values of that particular digital ports, right? So we saw that on the top right there were 14 digital ports. So to configure those ports, these three digital input output functions are inbuilt, and we just need to call these tasks in our code. We'll see this now when we start designing circuits and we start writing softwares. We'll see all this, and these are very frequently used. So it's important to know the functioning of these tasks. Okay. Now if you want to insert certain delay, right? So you can put delay, and this is in ms. So for example, what I'm saying is, right, for example, if you write delay 1000, right? So it means that you are delaying ultimately 1 second. The next task or the next instruction which you give to Arduino will happen after a delay of 1 second, right? Now you want to know how many, how much time the Arduino was on, how much time the Arduino was executing. So you can call micros function, right? You can assign this to any variable, let's say time. So time for which the Arduino was on, this can be give. This is in microseconds, right? And if you want the same in milliseconds, so this is for milliseconds. How much time the Arduino was on, right? So this is for that, right? So now this is why we needed to understand these basic inbuilt functions, because these are commonly used in almost all the codes. And this is the very basic when we start interfacing basic peripherals like LEDs, LCDs, and buzzers and all that, right? So it was important to understand these inbuilt tasks and functions. Now, in today's session, as we said, we are going to create two circuits, embedded circuits with Arduino. So the first one is what? So just to understand the problem statement, right? So we will take a red LED, right? And of course, we'll have an Arduino. So we want to repeatedly blink it after every 1 second. So this is our first problem statement. And what we take three LEDs, right? Red, green, and yellow, and take a Arduino, right? And we have to blink red, green, yellow, and then in reverse order yellow, green, red, right? So we know that what are the components, right? So what are the components which we are going to need today, that we know, right? So the first is of course your Arduino Uno, and I showed you that it was a revision 3. So this is the first component, right? Now what is the second one you need? Second one, you need a LED, right? So in the first problem statement, you need one, and then in the second, you need three LEDs, right? And see, you cannot connect LEDs directly to any power source, right? There are chances that the LED can blow up. So to limit the current, right? So to limit the current, we need also resistors, right? This is a very basic, that to limit the current so that it doesn't blow up, you need resistors, right? So you will need 3 at max for the second problem statement. And this is in general what you will need. And we also said, though you have now 3 LEDs, so you can connect directly to the Arduino ports, but a good practice is, right, to connect it to breadboard and connect the breadboard to Arduino, right? So we will of course need a breadboard, right? So we created our components based on the problem statements, right? So these are the components we'll need in both designing these two circuits. So let's proceed to designing these Arduino in TinkerCAD. Okay, so let's proceed to that. Now if you see here, I'll go over to TinkerCAD, right? Now you can start creating, once you go to this software online platform TinkerCAD, you can create, as I told you, you can create circuits, 3D design. We chose circuits, right? And I already started creating it, so you have my sample created here. So I will just open this. You can create Tinker this, right? So this white window will open, right? And here our first thing is to take all the 4 components which we decided. So we can select all, right? We can select all, and we can search for Arduino. So we took Arduino Uno R3. So this is our Arduino Uno R3. You can name this. So name is 1, right? Or you can also name this, component 1. Let's name it component 1, right? And now what we need? We need of course LED. That is our peripheral, right? So LED, right? We took LED. So this is our LED. Let's name this peripheral 1. Peripheral LED 1. and this is of red color, so let's keep it 1. Now this is one again resistor, so this is an additional component we need. So component resistor 1, right, and we are taking it as 1 kilo ohm, right? You can set the values from here, right? As I told you, we need this to limit the current to LED so that it doesn't blow up, right? And what is this? This is your breadboard. So component breadboard 1, right? So now we have taken all the 4 components, right? So what we decided earlier, that we will power the Arduino first so that we have enough ports to power the other peripherals. So what let's do, let's start connecting the ground, right? So we will take this wire, we'll click here on the ground power pin port of Arduino, right? Let's connect. So connecting it to minus, as you can see, let's change the color. So this on the left top, right, you can change the color. So wire color I am changing it to black, right? Now it's black. Let's give minus to this above line also, above row also, so that this is also at 0 volts ground, right? So this is the basic we need to perform for every circuit we design, right? This is a very good practice to do this way, right? Now let's connect power. Now let's give 5 volt supply to the other plus row here, right? Let's take 5 volts. We'll change the wire color later, no issues, right? So because the last wire color was black, so it is taking as black, but let's change this to red, right, to represent this 5 volt. Now let's connect here also. So this row is now at 5 volt. I am giving 5 volt supply to above row also, right? Right. So this complete row is now at 0 volt. This is as 5 volt. This one, black one, this row is at 0. This is at 5, right? So we are done with this now, right? Now let's take our LED, right? Now place it here. Let's place the peripheral here, peripheral LED one here, right? Now, so LED, what is the, so the long leg of the LED, the light emitting diode, right, is known as the anode, the positive part. This is a diode, right? So this is the positive end, the P channel end of the LED. Now this is the N channel end, the cathode, the short leg represented by short leg, right? And what we do, we take this, right? Let's connect this here. Let's connect the resistor, right? From we gave the power supply, we connect the resistor to the 5 volt end and connect the other end to the anode, right? So this now is connected. Now what we will do, you can take any 2 to 13, right? You can take any of the digital output ports and give that connection to the LED, right? Because we completed one part of the circuit, right? We took a 5 volt. Now the 5 volt is coming from here. If you see, it will come here. We connected a resistor and we connected to the anode end of that LED. Now the to the cathode end, right? The cathode end is still not connected. So what we will do, we will drive this from our Arduino, right? We'll give a pulse of 5 volts, or we'll give a 0 1 0 1 0, we will do, right? So our LED will blink, right? We want to give this end, let's connect it to 9, right? Let's connect it to the 9th digital output pin, right? Digital input output pin. We'll configure this as output so that we drive either 1 or 0 on this cathode, right? If it is now, let's suppose if it is 1, what will happen? There will be no voltage difference between the on the diode, right? On the light emitting diode, there will be no voltage difference because this is also at 1, which means 5, and from here also it's coming as 5, right? So it will not blow. Now if you drive 0, so there will be a voltage difference created and the LED will blink, right? That is what we should do. So we'll drive high low, right? So that will create the voltage difference, and if we'll put a delay and we'll drive the voltages high low so that it blinks after every 1 second. We'll put the delay of 1 second. That is our normal understanding of our code that we need to write, right? But this is a circuit which we are designing right now. Let's change the color of this. right? Let's keep it green because it is getting driven from right, this digital output port. Now we need to configure this port as an output, right? REST connections we have done, right? So REST connections looks proper to you, right? Now what we will do, we'll write a code. So here in TinkerCAD, right, you have been given a window to write the code. Normally in hardware, when you actually create a physical hardware, you have this Arduino and you have done all these connections in the same way. This exactly remains same on the physical. If you take a physical Arduino, physical breadboard, everything, and you connect it, this remains the same. But for writing a code, you have an Arduino IDE, which I will show you in the last part of this session, where you can write the same code and you can dump it. So since you have connected a USB plug, this is a USB plug to your laptop, you compile the code and you can dump the sketch, right? Sketches will be the output firmware file which will be generated, and you dump the code onto this Atmega. It is dumped and then it will run, it will blink the LED. That is how you will do it on a physical hardware. In this software platform, this code window has been provided to you, right? So here we will write the code. Now in this code you need to understand two basic things. So what I did was, I said that I am driving my cathode end of it from the digital pin 9, right? So let's take a variable, right? I took a variable LED pin or output LED pin. Let's name this as 9, right? So now you will see that in all the Arduino codes, right, there are two tasks which are by default present, right? So this is for initialization or setup for one-time variables, right? So here you can initialize or set up your one-time variables, right? So for example, I want to always keep this pin as an output. So what I told you, that there is an inbuilt task pin mode, and I said that I want to drive the digital pin 9. So OLED pin, right? I have taken this name from variable here, OLED pin 9, and I write it as an output. If you would have taken it as an input, you would have written input, but now the function is to provide the voltage to the LED. It's an output of the Arduino, right? So we are writing it as output. So this is the only one time setup which we need to do, right? Rest we want to, drive the voltages on this digital pin to 5 and 0 volt, right, alternatively, so that it blinks after every 1 second, right? So this is what it is. If you see here what I did, now this loop, right, this is also common, right? So this will repeat, right? Code inside this block repeats forever, right? Repeats forever unless reset, right? Okay. So now what I do, I want to write, right, a 0 and 1, right, to this pin. So what I took a digital write inbuilt function, right? I took the pin number, which is 9, right, and I'm writing it high. I wait for 1 second. I told you that we need to blink the LED after every 1 second, right? Now digital write OLED pin low, right? And then I again delay it for 1 second. So this will repeat in a loop. This was a one-time setup, right? So these two tasks you will see by default. Inside that you will need to write the code. This will repeat forever, and this setup is a one-time setup, right? So we have written the code, right? We are driving the digital output pin 9, right? Setting it as output first and driving high and low to this pin, right? So let's start the simulation, right? Once you have written this code, what happens? If you see, it's blinking, right? So this is our expected result, what is happening, right? So I will stop this simulation, right? Now, if you want to blink fast, I can change this. I can change this number here, the delay, right, to 500, right? So let's start. Please see, it's blinking faster. If you see here, right? So now why I decided to create a variable for the output pin, so that you don't need to change if you directly give the pin number, right? If you write 999 here, at all the places you need to write change the code if you change the pin number, right? So that is not a good code practice to do. You declare the variable of the pin number. This is what was my LED pin, right? Output LED pin. I declared it as 9, and now this setup and loop, right, will run, or setup will run once and loop will run together, and it will start creating, it will start blinking your LED after every 500 milliseconds, right? 0.5 seconds it will start blinking. So this is a normal LED interface which you need to we interfaced it to Arduino, and we created this blinking an LED after every 1 second, right? So now let's go to another project which we decided to do, right? So in this project, what we do is we said that we'll take 3 LEDs instead of one, right? And same thing, we will blink one after the other first and then in a reverse way, right? So now what are the same components we need? I told you we needed an Arduino, right? We needed a breadboard, we needed 3 LEDs, we needed 3 resistors, right? And that's it. So now again, we start with the breadboard connection, enabling breadboard to have multiple, so that we are able to drive multiple voltage levels and connect many peripherals, right? Suppose you have 10 LEDs. Now it would be very difficult and messy to connect all those LEDs to directly to these output digital output ports here in the Arduino. So breadboard gives you that clarity, and right, and it is gives a much more clearer output ports to connect, right? So what we did, right, we gave this red, if you see, plus 5 volt, right? Now we took this black again, we gave this row as 0 volt, right, ground, and we connected the top here minus and plus to same 5 and 0 volts, right? Now we took 3 LEDs here, this is green, right? We took this as yellow, right? We took this as red, right? We connected 3 LEDs same way as in the last uh, problem statement. We connected 1 LED, right? So we connect the resistor all to this so that we limit the current, it doesn't blow up. It's a good practice to do. And in real hardware, when you create a physical model of this, right, on real Arduino and breadboard, you will always need to have a resistor, right, so that it limits the current, your LEDs don't blow up, right? So we connected this, right? So our setup is very simple. This is just we are replicating 3 LEDs instead of one, right? Now we go to the code part of it. So code part, what we did was, right, so we took we took a timer of 200, right? Now we are setting this pin mode, this pin output, right, to output like we, so what we have taken, 3 4 and 5, 3 4 and 5 are the digital pin outputs which we have taken, okay? And we set this one time setup we do, we configure this as output, right? We'll configure this as output. So we take a for loop, right? Since it is a C++ backed environment, so we create this for loop, right? And so, right, let's move this just to, now what we do, so we have set up this all these pins, right? This pin, it will take 3 4 5, and it will create this as an output port. Now the loop we want to run, so what we have done, we again drive 3 4 and 5 in one order first, right? We drive high low, right, and then this loop will repeat for 4, and this loop will repeat for 5 ports. So it will drive red yellow green. Now what we do is, we have, if you see here, we'll repeat this in a reverse order for these pins, right? So we take the first, the fifth digital output port, right, drive it high low, right, then we take the fourth, and then we drive the three. So in a reverse order we are doing. So this is what our problem statement was, right? So same way, nothing changes, we are just adding a for loop, right? So that we don't have to, you can also do this multiple times, pin mode, this pin 3 output, but why to have such repeated codes, right? You can always have good coding practices to take a for loop, right, and drive this same time, just changing the pin mapping, right? We drive 3 4 and 5. So now if you start this simulation, right, see, it's changing, right? So this is the experiment or problem statement we wanted to solve, right? Nothing much. We have taken the same variable here. Earlier, the only thing was that the timer which we were taking was of 500 and 1 second. Now we have only 200 milliseconds here. So that will be the delay, right? But everything else remains the same. We are just repeating one LED function, right? Driving the digital output port 3 as an output and then repeating it for 4 and 5, and then driving the values, right, using the digital write inbuilt function, and driving it high 5 volts and then low 0 volts so that it blinks, right? There is a voltage difference created across these LEDs and the LED blinks. So these are the two basic LED interfacing problems which we did, and we will build on top of this, and we interface much more peripherals, like much more bigger peripherals to Arduino, right? So thank you for joining today.